Hi, listeners. Welcome back to the Rule Your Pool podcast. I'm your host, Eric Knight, with Orenda and Hasa, doing this one alone. This is episode 163, and I'm calling this episode The Three Constants. But before we get into that, if you've been listening to this show for a while, been reading our blog, you find our information helpful, you use the app, for instance, we do episodes and kind of chunk out this information in little bits and pieces, and we probably teach 20 to 30 different classes. How does it all weave together? And that is one of the main questions that we get from you. I see too many pool pros out there struggling with their water, and they're frustrated with problems that keep coming back. For instance, flakes in a saltwater pool, scale on spillways or tile lines or in a heater, corroding a heater and you get a turquoise spa, or discolorations on the plaster right around the perimeter, or a lighter color around the main drain. Or maybe it's I can't hold chlorine for a week. Or maybe it's I keep getting algae and I just can't get rid of mustard algae. Or maybe I have black algae. All of these questions can be explained with a fundamental understanding of water. And in water chemistry, we break it into two parts. There's what we do to water, which is water quality, keeping the water safe, clean, and clear. And then there's water balance. And water balance can be summarized in one word: physics. And we often conflate these two things in the industry, and we think, oh, well, my water's clear and it's chlorinated, so it must be balanced. Alternatively, maybe we have balanced water and we might think it's safe, but it might not be safe. And of course, the first priority that we have as pool professionals is to keep the water safe. Trust me, I'm a swimmer. That's my ultimate priority as well. However, it's really hard to do that as a pool professional who comes once a week, and you've got to hold that for 7 days. Well, there's a lot more to the story. It would really help to understand how alkalinity plays into this, how the pH ceiling plays into this, and how the rising pH up to a certain point affects not just chlorination, but how well chlorine stays attached to cyanuric acid stabilizer. A lot of people don't know this. We've done episodes on it, but how does it all flow together? These are the questions we've been getting for years because we have so much content. I mean, we're approaching 200 blogs. We've got tons of help center articles. This is episode 163 of the Rule Your Pool podcast. You name it. We've got a lot of information out there, and all of it's available in the app. It's information overload. And so what a lot of pool service companies have been asking for is one place. Can you make us a book? Can you put it together? Can you tell the whole story in context so that we have something to reference back? And the answer now is yes. We've partnered with WaterShape University to create the first ever water chemistry certification course. We will be teaching this, or I guess I will be teaching this, at the Northeast Pool and Spa Show, which is going to be in Atlantic City. That date is going to be January 27th, 2025. And I'm also going to be teaching it at the Western Pool and Spa Show on February 6th, 2025. This is only for pool pros. Eventually, we may get more into this for homeowners, but this is for pool professionals who service multiple pools every single week. Of course, it applies to commercial pools. It applies to residential pools because water chemistry is, well, water chemistry, not just pool chemistry. So most of it is going to apply to any swimming pool and beyond. But we want to put it all in context so it tells a story. It tells you what water has been trying to tell you this whole time. Why does it behave that way? What does water actually want? What is it telling us? And I get so many questions from companies that they call up and they say, hey, your podcast has helped us so much. And it means the world to me. It really does. The feedback is awesome. I'm so glad you find this show valuable enough that you keep listening. And a lot of you have told your friends, and we greatly appreciate it. We can keep producing all these podcasts, but at some point, it's really hard to find the information you're looking for. If you've got a specific question, you've got to search our help center, you got to search our blog, and there's so much information in there. We wanted to put all of this in one place because we do want to help you. We want you to have a resource that is easy to use. It's all there. We wanted to put it into one class, and we've never been able to do that, primarily because we are given usually about 90 minutes in a class, sometimes 2 hours, very rarely more than 2. Well, this is an 8-hour class. It's all day, and it's accredited. WaterShape University is an accredited higher education institute, and you will get those credits. And there's a cost to that because accreditation has a cost. But if you are looking to really up your game, pool professionals, and you want to really understand the substance that you make a living treating, I strongly recommend you take this class. Shameless promotion. I mean, I did write the thing, but I cite all of my sources. It's great information. And if you really want to rule your pools, plural, I hope to see you there. So again, January 27th in Atlantic City, I'll be teaching this. The class number is Watershape University Service 1211. It's called Essential Water Chemistry. You can go on their website, just search my name, Eric Knight, Knight. You'll find it that way too. Sign up on their website. You could do the same thing for the Western Pool and Spa Show. That'll be February 6th. Now that we've talked about that, let's hit the intro and talk about the 3 constants. Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go. Those of you who know me know that I'm traveling constantly. I teach a lot of classes. A lot of common problems happen. And so what I've evolved into over the past couple of years is asking a big question at the beginning. Last year's question was, what does water want? Have you ever thought about that? Now, when we say you're treating water, does that mean you're imposing your will upon water and trying to beat it into submission so that it behaves according to a book that it never read? Because for most pros, that's what it means. But let's dissect that sentence. Treating water. Let's replace the word water with spouse for a second. I just got married. If I impose my will upon my spouse and try to force her to do something that she doesn't want to do, that's not treating my spouse, is it? That's not treating my spouse at all. That's serving me maybe, but nobody wins in that scenario. So when we treat water, we should be doing what's in the best interest of water. That's treating. So when we treat water, we might want to know what water wants. And if you've been paying attention to this show in the past few years, you know that water will always seek its natural state. That's all it wants. It wants balance. Balance as defined by physics, not by you and me, not by mankind, not by a book. Balance is determined by laws of nature. The best known way that we can quantify that balance is using the Langmuir Saturation Index, the LSI. That's how we measure it. It's not perfect, I'm sure, but it's the best known thing that we have. And if it ever gets better, we'll let you know. But for right now, that's what every industry uses. Water will always seek its natural state. That's a fact. This year, I've been asking people, what constants do you have in your business? Things that never change. Whether you can control them or not, just something that never changes. It always happens. Do you control traffic? Do you control prices? Do you control your customers' attitudes? Their bather load? Whether or not they have dogs getting in? Do you control anything, really? I mean, you have a business where you're traveling to multiple pools every single day. What can you really rely on? Yes, of course, there will be taxes. Yes, of course, there will be traffic, but they are variables. They move, they change every day. They're never good, maybe, especially in big cities. But you can't control that. You can't rely on traffic times. There's not a lot that you can rely on, but there are 3 that we can think of, and they will never change. They're not going away. The first one I already mentioned. Water will always seek its natural state. Operative word is its natural state. Not necessarily what we want it to do. Water's going to do what it has to do to get back to balance. And once again, we measure that balance using the LSI. Another way of saying this is water will seek to get back to LSI balance. If it's not there, it's going to either eat, if it's low, to get enough calcium saturation to get balanced again, or it's going to scale to get rid of calcium to get back down into balance. One way or another, water will return to its natural state of balance. That's a constant. How it does that may change, but you can rely that's going to happen. The second constant is air is going to equalize with any gases dissolved in that water. This is called Henry's Law. We talk about this a lot. We have a lot of episodes about containing pH and why the pH rises. That's the same physics. Henry's law states that any gas dissolved in a liquid must equalize with that same gas above the liquid. That's a law of physics, not an opinion. We see this with carbonated drinks. You open it up, that drink will eventually go flat, but you see bubbles at first, and then it goes flatter and flatter, slower and slower over time. That's Henry's law. Your pool is carbonated because we have carbonate alkalinity. When you have a carbonated pool and it's more carbonated than the air above the pool, your pool has to go flat. And when you lose CO2, your pH goes up. So your pH rises until it goes flat, and we call that the pH ceiling. That's not going away. The third constant is just as guaranteed as the first two: gravity. And you might roll your eyes, hopefully not when you're driving. But gravity actually matters a lot more than you give it credit for. I don't have to agree with gravity, but I have to deal with it. Any of you who do plumbing work or repairs, you're all too familiar with gravity. What would happen if you are downhill from a pool and you plumb that pump below the water line and you don't close a valve when you open the pump lid? You're going to get wet feet, aren't you? It's going to flood. That's gravity. When you plumb, water always finds its own level. That's gravity. The whole concept of hydraulics is based on gravity. Where is fluid going to go? Look at what just happened in Western North Carolina. All the water had to go to the valleys, and they had massive historic flooding. That was gravity. I've never seen a pool fill from left to right on a startup. It always fills from the bottom up. And we can tell a lot of plaster problems based on that fact. We can always rely on it. So when I see vertical lines, that's probably not from the startup. It's probably from an acid wash or rain that went straight down those sides, because the pool didn't fill left to right. It filled from the bottom up. Now, if I see horizontal lines, that's a different story. You see my point? These are things that you can rely on. They're never going to change. When you put acid in a pool and you don't dilute it, muriatic acid is 18% denser than water. It's going to go to the bottom. This is why you dilute it. This is why we want a clean white bucket on our truck. We want to dilute our acid so it doesn't do that. If you saw the video we posted on social media, you can see what muriatic acid did in my pool with red food coloring in it. It went straight to the bottom. And I poured it in 3 different ways so you can see the contrast. But here's my point. These are the 3 constants, and you can really build your business on them because they're not going away. Now, you may not control them, but you don't have to. You can rely on them. None of us control gravity, but we know it's there. I go to the gym. I know that that barbell weighs 45 pounds every single time. Gravity didn't change. So I want to give you one example. This is just one of many, but this is something that we can talk about in classes and whatever, and we will definitely talk about this in the water shape class in depth. Let's take a typical pool in the summertime. We're going to do a scenario here that's pretty common. Pull up the Orenda calculator if you're not driving and go ahead and plug these numbers in. So let's say this service pro is new to the business and they are a good student and they are doing their best to stay in the ideal ranges for range chemistry. So 7.4 pH, go ahead and plug this in on the left side of the Orenda calculator. 7.4 pH, the ranges say 80 to 120 alkalinity. So we're going to go right in the middle. We're going to put 100 alkalinity in there. And then 200 to 400 calcium. Right in the middle is 300 calcium. And then we're going to do, let's say it's a saltwater pool, 3,800 TDS, which includes the 400 when you add up alkalinity and calcium. Our pillar 4, if you've taken our 4 pillars, is to stay 50 or less on cyanuric acid for residential pools, 15 or less on a commercial pool. So let's just say it's a residential pool and we're going to put it to 40 CYA. We're at 82 degrees, 7.4 pH, 100 alkalinity, 300 calcium, 40 CYA, 3,800 TDS. And we have a red LSI number of minus 0.34. That's aggressive water. That means that water is going to etch cement, damage vinyl liners, and attack fiberglass gel coats. It's not going to be very effective against the latter, but over time, if you persist with having aggressive water, it's looking for calcium. It's going to be hangry and it's going to be looking for calcium because water is always trying to return to its natural state, constant number 1. Now, you set it to 7.4 and that's great, but a quarterback doesn't throw the ball to where the wide receiver is. A good quarterback throws the ball to where the wide receiver is going. So where's the pH going? You may set it to 7.4 right now. Congratulations. But by the time you're in your vehicle to leave for the next pool, it's not 7.4 anymore. unless you have chemical automation that's constantly dripping acid in that pool, or maybe CO2. But if you don't have automation, it ain't 7.4. It's rising. And maybe you have a trichlor feeder that also suppresses it, or maybe you have an auto cover, which can suppress it as well. But the force of physics on that pool is saying that pH has to rise, because right now it's in an untenable position. This is unnatural for water. The pH ceiling, right under the pH, is 8.31. So it's not going to stay at 7.4 for long. It's going to rise to 8.31, except that you're in the red right now, which means it's going to etch some plaster. So if you have a plaster pool, it's going to etch. And it's going to spike the pH because the pH of calcium hydroxide is 12.6. So it doesn't just go to the ceiling, it's going to exceed the ceiling. But let's just pretend that in this case, it's not a plaster pool. It's going to be something that doesn't have calcium readily available. It's going to be vinyl liner or fiberglass. So it's just going to rise to the pH ceiling. Take that 7.4 up to 8.3. Oh boy, now we're in a purple number. But that's where the pH was always going to go. Pool pros find this scenario all too common. You set the pH, trying to do the right thing, but the physics disagree with that. So when you come back after a week, the pH is at its ceiling. Now, the most common test kit doesn't go over 8.0 on the pH. You just know it's over 8. We don't know exactly what it is, but it's over 8. Well, where it really should be is at that pH ceiling. That pH ceiling is the limit. That means you can't lose more CO2. So the pH goes there and it stops rising. That's good to know, but that's not a convenient number. It's over 8.3. We're going to have scale forming condition in that pool. And this is a saltwater pool in this scenario. So we're going to have flakes in that saltwater pool. I can almost guarantee it. And if you have a heater, you're probably going to scale the heater. You're probably going to have scale on the tile line or spillway as well. And so you've slingshotted. You went too low when you corrected the pH to 7.4 and took the LSI into the red, which is bad. And then it slingshots up because the pH has to naturally rise. And I should say it would slingshot more if it was a plaster pool because it would etch too. But let's just say it goes right up to the pH ceiling. Now you're scaling. So you went to both extremes. And yes, in between you were balanced for a few days. But by the time you get back, the LSI isn't balanced. So the water has to scale. It has to get rid of that calcium to get back into its natural state. But by the time that happens, you're back. It's Tuesday again. And you see that pH really high and you think, gosh, I can't keep that pH down. That's really annoying. Instead of going to 7.4 this week, I'm going to go 7.2. Am I the only one guilty of that? Something tells me if you're listening to this, you've tried that before. And what happened? I'm guessing that pH went even higher when you got back. And in that case, that was your fault. But in most cases, it's not. Because the pH has to rise. The pH has to rise because you have a carbonated pool. And your carbonated pool has to go flat. And every time you add acid, you are recarbonating it at the expense of alkalinity. Acid converts bicarbonate ions into carbonic acid, which is dissolved CO2, and a very small portion of dissolved CO2 is carbonic acid, so most of it just bubbles out as CO2 over time. And your beer goes flat again. Your pool goes flat, I should say. The pH goes back up. Come back. Alkalinity is a little bit down, but your pH is high. What you did last week has now been undone. The pH had to rise. Remember, there's two constants here we're talking about besides gravity. Gravity's the third. The water will always seek its natural state, but the air will seek equilibrium with gases in the water. That includes oxygen, but the one that matters to us is carbon dioxide because we have carbonate alkalinity. That's our buffering system. pH is about hydrogen ions, but if they're all bound up in the buffering system, a good proxy for that is CO2 because it's carbonate. So the less CO2 you have in your water, the higher the pH, and vice versa. You want to lower the pH, increase the amount of CO2. Maybe you put a CO2 injector on it, or maybe you just put acid on it to burn through alkalinity to create more CO2 to temporarily lower the pH again. That is pH suppression or pH correction. It is not pH control. You can only alter it temporarily. Does this sound familiar to you? Because if this does sound familiar to you, you are not alone. I have seen too many pool pros suffer and struggle with this problem because they didn't understand what they were up against. And it's not because you're not good at your job. No, the people I'm talking about are generally very good at their job, but they've been told incomplete information. The truth is, the three constants are never going away. They never did. They've always been there, eternally. As I say in the class, these laws of physics were here before the dinosaurs were. They're not going away. You probably just didn't realize it. You're up against something you can't beat. I say this in class as well. An airplane can defeat gravity temporarily, but it takes a tremendous amount of fuel and propulsion to do so. But one way or another, that plane is going to come back down, hopefully safely. Gravity always wins. So does Henry's Law. So does the LSI. These are the three constants. They're not going away, and you have a choice. You can either build your strategy for pool care around them, or you can try to fight them. There is a good way to do this. You can use these physics to your advantage. We talk about it a lot on this podcast. If you have the time to go back and listen to all the episodes, more power to you. It's all in the calculator. It's all in the Orenda app. You can find it there too. But if you want to know where it all is, once again, you can take the Watershape University class. It's an 8-hour class where we're going to really dive deep, no pun intended, on water. We're going to understand water to the nth degree. And you will know what you're up against. So I'll get off my soapbox now. I hope this opens your eyes that there is a better way of doing things, and you can rely on these three constants to do it. This has been episode 163 of the Rule Your Pool podcast. I'm your host, Eric Knight with Orenda and Hassa. I don't know what we're talking about next time. I got a lot of things on my list. We'll find out. I appreciate all of you. Have a happy Thanksgiving. Have a wonderful holiday season. Thank you so much for still being here. If you have any questions, check out ask.orendatech.com or shoot me an email, podcast@orendatech.com. See you later. Take care.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.